In this video, you will be learning about one-to-one functions. So let's recap what you've already learned from the previous videos. You now know what an inverse is, and we demonstrated this with the example of the square root being the inverse of something being squared. You also know how to find an inverse algebraically, and this was done by switching the x and y in the original equation and isolating for y. And finally, you learned the two different methods to graph an inverse. So there was the first method, where you used image points from the original equation, and the second method, where you switched the x and y coordinates in the original. So if you had 1, 2, it becomes 2, 1. So now we'll be showing you one-to-one functions and how to recognize if something is one-to-one. So remember how for something to be a function, it needed to have one output for every input. In a one-to-one function, it still needs one output for every input. However, the difference here is that it also needs one input for every output. So to help you understand, we're going to show you an example with a table of values. So the x values are the inputs, and the y values are the outputs. So this is a function because there are no repeating x values. None of them are equivalent to each other. But if you notice in the y values, there are two 9s. This means that it is not a one-to-one function because it has two repeating y values, and a one-to-one function cannot have two equivalent y values. So how can you tell if something's a one-to-one function in a graph? So with the table of values, we checked to see if it was a function by making sure that no x values were equivalent to each other, so there were no repeating x values. And we checked if it was a one-to-one function by making sure that no x values or y values were repeated or equivalent to each other. For graphs, we can determine if it's a function by seeing if it passes a vertical line test. So this is a test where if you put a vertical line anywhere on the graph will only touch it in one spot at a time, no matter where you put the line. You can check if it's a one-to-one function by seeing if it passes both the vertical line test and the horizontal line test. The horizontal line test is the same thing as a vertical line test, except it's a horizontal line except a vertical line. So here we will show you an example by drawing a graph and doing both the vertical and horizontal line tests on them. So this blue line is the vertical line test. This graph passes the vertical line test because only one part of the graph will touch the vertical line at a time, no matter where you put the line. So this means that it is a function. So see, no matter where you put the line, it'll only touch the graph once. This purple line is the horizontal line test. So you can already tell that this graph does not pass the horizontal line test, since the graph touches the horizontal lines at 2 points at one time. So that means that this graph is a function, but not a one-to-one function. Here's a couple to try on your own. So for these two graphs, you should find out which ones pass the horizontal line test, which ones pass the vertical line test, and if any of them pass both. After that, determine if it's a function, not a function, or a one-to-one function. So here you can take the time to pause and solve it on your own before continuing to see the results. Are you ready for the solutions? So here you can see that it does not pass the vertical line test, and it doesn't pass the horizontal line test. We already knew after it didn't pass the vertical line test that it wasn't a function, but we were just checking to see if it passes the horizontal line test. So example 1 is not a function. Example 2, you can see passes the vertical line test, and it passes the horizontal line test. So this means that example 2 is a one-to-one function, since it passes both tests. So did you get the right answer?